Ever wonder why your radio can sometimes pick up stations thousands of miles away? But here's the twist. It's not magic, or even modern tech. The secret lies in a volatile, invisible force high above us, constantly shaped by the sun. This is the first in a series on understanding radio propagation. Many new and even seasoned ham radio operators find the effects of radio propagation a mystery. The goal of this series is to help unravel that mystery. Ever wondered how you can hear radio stations from across the globe? Or why sometimes your favorite AM station fades out during the day? The answer lies high above us, in a layer of our atmosphere called the ionosphere. The ionosphere, located between 50 and 600 miles above Earth's surface, is a unique region where sunlight interacts with the atmosphere in a fascinating way. The sun constantly emits a stream of energy, including ultraviolet radiation. When this radiation strikes the ionosphere, it strips electrons from atoms and molecules, creating a soup of charged particles, ions and free electrons. This ionization process is the key to long-distance radio communication. Radio waves, which are a type of electromagnetic radiation, can interact with these charged particles in the ionosphere. Depending on the frequency of the radio wave and the density of the ionosphere, these waves can be reflected. Like a mirror, the ionosphere can bounce radio waves back down to Earth, allowing signals to travel far beyond the horizon. This is how shortwave radio broadcasts can be heard across continents. Some radio waves are absorbed by the ionosphere, preventing them from reaching their destination. This is why AM radio signals often weaken or disappear during the day. The ionosphere can also refract or bend radio waves, changing their direction of travel. The effect is similar to the way light appears when going through a glass of water. This phenomenon can also contribute to long-distance communication. But the ionosphere isn't static. Its behavior is constantly changing due to the ever-changing activity of the sun. The solar cycle. The sun goes through an approximately 11-year cycle of activity, with periods of high and low sunspot activity. Sunspots are dark patches on the sun's surface, associated with intense magnetic activity. During periods of high sunspot activity, the sun emits more radiation, increasing the ionization of the ionosphere. This can lead to improved long-distance radio communication on certain frequencies, but also increased interference and signal fading. Solar flares. These are sudden, intense bursts of energy from the sun. Solar flares release a flood of radiation, including X-rays, which can significantly disrupt radio communication. They can cause sudden ionospheric disturbances, SIDs, leading to signal absorption and blackouts, particularly on shortwave radio frequencies. Coronal mass ejections, CMEs. These are massive eruptions of solar material that can send a shock wave of charged particles towards Earth. When these particles reach Earth, they can interact with the Earth's magnetic field, causing geomagnetic storms. These storms can severely disrupt radio communication, affecting GPS signals, satellite operations, and even power grids. These solar events, while potentially disruptive, also make radio communication a fascinating and unpredictable science. Predicting radio propagation. Scientists and radio enthusiasts constantly monitor solar activity to predict how it will affect radio communication. Factors like the current sunspot number, solar flux, and geomagnetic activity are used to forecast the best times and frequencies for long-distance radio contacts. Ham radio operators, amateur radio operators, hams, are particularly skilled at understanding and adapting to these changing conditions. They use various techniques to overcome propagation challenges and connect with other hams around the world. So, the next time you tune in to your favorite radio station, remember that the quality of your reception is influenced by the dynamic interplay between the sun, the earth, and the invisible layer of charged particles high above us.